All right, so before we get into the notes, I want to review a little bit of questions from yesterday. So let's look at this problem. This isn't in your notes, we're just going to review first. If the triangle below is dilated by a scale factor of 1/3, what are the coordinates of the new triangle? Scale factor of 1/3. What's going to happen to that triangle? Get smaller. How do you know? It's less than 1. All right. So how can I find the new ordered pairs for that smaller triangle? What do I need to do? Multiply everything, each x and y value, by 1/3. All right, so let's do that. So I need to find a prime. What is going to be my new ordered pair? I need to find a. -9 times 1/3. You got a calculator. -9 times 1/3. Do you agree with him or not? -3, I agree. All right, do the y coordinate. 6 times 1/3. Hayden, you don't need computers. 6 times 1/3 is 2. All right, let's do b prime. Find my new ordered pairs. I have my b is at -9, -6. It's not -3 and 2. What is -9 times 1/3? -3. -6 times 1/3. -2. So it's not the same. My y values were different. All right, now let's look at c prime. What are my ordered pairs from c prime? -1, I like that. -2. So if I go to plot that, you mean to tell me that this triangle is going to be smaller? All right, let's see. -3, -2, or +2, I mean. There's a prime. -3, -2 is b prime. -1, -2, c prime. Ah, it is smaller. It is 1/3 smaller. Or 3 times smaller. All right, so let's look at the next one. What is the scale factor of the dilation shown below? Think about it. Think about what we did yesterday. First, I need to identify what? If I'm going smaller or bigger. So, which one is my old and which one is my new? What do you think? Yes. It's getting smaller. Okay, all right, well, we'll see if we're right or not. So he says we're going smaller. Whoops, wrong way. He says we're going smaller. And I would agree, this is the new. How do I know this is my new figure? It has that prime symbol. So this is my old. So if I'm going smaller, what answer choices could I eliminate? I could eliminate A and D. And then what do we use to find our scale factor? What did we use yesterday? What method? I can either set up my equation or I can do new over old. So my new value is 3. My old side value is 18. 3 divided by 18? 1/6. Use your calculator. Because your brain's automatically going to see the 18 and 3 and think 6. But we know it can't be 6 because that's larger. 1/6. Use your calculator. 3 divided by 18 gives me 1/6. Okay? All right, so this is what we're going to start getting into today. We're not quite in our notes yet. We're just going to kind of talk about it. We want to know how to write a scale factor algebraically, how to write the rule. What are the directions that we have to do for dilation? So if an ordered pair is 2, 4, so I've got an ordered pair 2, 4, and I want to dilate it by a scale factor of k. What do I have to do to this ordered pair in order to get my new point, my new coordinates? What would I have to do? Think back to what we did on our homework. What did we have to do to those ordered pairs to get the new prime ordered pairs? We multiplied it by what? The scale factor. Well, in this example, what is my scale factor? K. So I had to take my x value times k, right there, k times 2. I have to take my scale factor again, times my y value, k times 4. Does everybody see that? Okay. But now, what if my scale factor was 3? What would be my new ordered pair? 6, 12. How did you find that out? What did you have to do? So instead of multiplying by k now, we're multiplying by 3, right? So 3 times 2 is 6. 3 times 4 is 12. That would be my new ordered pair, right? So we're going to use that process to be able to write our rule, okay? All right, so let's look at our notes. Our notes ask us, what if we see something like this? This right here, this is the rule. This tells us what to do. Well, if I look at this, what does this mean? What am I doing to my x and y? What is that? If I'm multiplying it, so you're saying that this means 1/4 times my x coordinate, 1/4 times my y coordinate. Is that what that says? I would agree with that, absolutely. 1/4 times my x, 1/4 times my y. Guys, if I'm writing this down, it's probably important. You should probably be putting it in your notes. Put that in your notes. You have space right next to it. Up on the top. All right. So if we know that I'm multiplying my x and my y value by 1/4, what does 1/4 represent? 1/4 of something, you're right. What did you say it was? That is my scale factor. 25% would also work. Now, if that's my scale factor, just like before when we multiplied them both by 3, well, here I'm just multiplying both my x and y coordinates by 1/4. So that means this number right here and that number right here are my scale factor. And what are we doing with that 1/4 in the x? What's happening there? What operation? Multiplication. We are multiplying. Anytime you see a rule that involves multiplication, that's automatically scale factor. Dilations only use a rule of multiplication. All right, so here's the rule, same rule that we had on the previous slide. Is this rule going to give us an enlargement or reduction? How do you know? All right. It gives us a reduction because my scale factor, that 1/4 is less than 1. How do we know? Because my scale factor is less than 1. I believe that's a question in your notes. How do you know? Because my scale factor is less than 1. 1/4 is less than 1. All right, so let's think about some questions here. True and false. Each vertice or side in the same image must be multiplied by the same scale factor. Ooh, let's see. First of all, what's a vertice? If I have this rectangle, I know this is a side, right? Where are my vertices? The corners, the points. If I'm talking about just one, that's called a vertex. The plural, all of them together, are vertices. So, do they all have to be multiplied by the same scale factor? Or can I multiply my x-coordinate by a fourth and my y-coordinate by a third? No, you can't. They all have to be multiplied by the same scale factor. Remember that whole thing, what you do to one, you do to the other. That still applies through math. So this is true. All right, next question. The new image does not have to be the same shape as the pre-image. The new image does not have to be. So that means I can have different shapes, is what this is saying. No, I cannot. That is false. I have to have the same shape. I just can have different sizes. I can get bigger or smaller. And the last, oh no, that's not the last one. Think about this one, what we did yesterday. We represent the scale factor with the letter S. False. Very good. Do you remember what letter we used yesterday? K. Very good. That is false because we use the letter K. And the word dilate only refers to images that get bigger. True or false? So, they can only get bigger. That's the only way we can dilate.
No, that's false. That's not true.
What else can we do? I can get smaller. So that's a false statement. They wouldn't call that a dilation, though. So that is a false statement because I can do bigger or smaller. All right, look at these two figures in your notes. Figure S and figure S prime. First of all, when you see two shapes, you better label them old and new. That help your brain out. Do some of the work for your brain. How do I know which shape is my new shape? The new shape has the prime. So this bigger trapezoid is new. The smaller trapezoid is old. So we're going from a little shape to a bigger shape. So what do we know about the scale factor of a bigger shape? My scale factor has to be greater than 1, right? So if I know that my scale factor has to be greater than 1, out of our choices A and B, which one has to be the rule? Why? Oh, so A, because our scale factor is greater than 1. What's our scale factor in A? 1.5. Very good. So then the next question in your notes, how do you know that B cannot be the answer? Because the scale factor is less than 1. 1/2 is less than 1. So I know B cannot be the answer because the scale factor is 1/2, less than 1. All right, y'all are rocking the scale factor stuff. All right, so now here's where we get to write the rule. Okay? Remember, the scale factor tells us to do what? Multiply all the coordinates, right? Multiply the x by the scale factor and multiply the y by the scale factor. What one? How do you know that B is not the answer? Because 1/2 is less than 1. All right, so if we look at problem number 1, what's my scale factor? 2. So if I were trying to find my rule, I know that I have to take my x coordinate times 2, right? And I also have to take my y coordinate times 2, right? But we're 8th graders. Is there a proper way to write x times 2? 2x. Very good. We know that fancy proper way. And what's the proper way to write y times 2? 2y. There is our rule. Right there. We just wrote the rule for that dilation. Okay? Let's look at number 2. In order to write the rule, I have to take my x value times my scale factor, which is what? What's my scale factor for number 2? 1/2. My y coordinate times, what's my scale factor? 1/2. Is that the proper way to write it? No, let's make it proper. What would I write? 1/2 x, 1/2 y. Very good. All right, can you do the last 3? Okay, good. You can do it. What is the rule for number 3? 3.5x, 3.5y. What about number 4? What is the rule for number 4? 4/5 x, 4/5 y. So, if my scale factor is 6, what's the rule for number 5? Okay, now let's back it up. Number 1, is that going to be an enlargement or a reduction? How do you know? My scale factor is greater than 1. What's the scale factor in that rule? 2. Very good. What about number 2? Enlargement or reduction? Reduction. What about number 3? Enlargement. It's greater than 1. What about number 4? Reduction. 4/5 is less than 1. My scale factor is smaller than 1.
Now, 5 is definitely E.
5 is definitely enlargement. It is 6 times bigger. My scale factor is larger than 1. All right. The next example isn't in your notes, but you do have some white space at the bottom of your notes if you need to add it. No. All right. Now let's look at this one. If a triangle has the vertices of R is at the coordinates 3, 6, S is at -2, 1, T is at -4, -2. The triangle is now dilated so that the vertex T is now located at -8, -4. Well, if that's the new T coordinate, what do we call that? T prime, right? So that is T prime. They want to know what is the algebraic representation. That's just a fancy way to say what is the rule of this transformation. Oh, let's see. How did you figure that out? So you divided the new by the old. What ordered pairs did you use? We used ordered pair T and T prime. So did I even need the ordered pairs for R and S? No. So if T was -4, 2, T prime is -8, -4. And you just said you just used new over old? All right, let's try it. New over old. What's a new value? What's a new coordinate? Do you want to use the X or the Y coordinate? All right, I heard people say the X. So my new is 8. What is my old corresponding coordinate? -4, the X value there. Oh, I forgot the negative. There we go. So what is -8 divided by -4? +2. And remember, I'm going from old to new. Couldn't I say -4 times what gives me -8? The +2. Well, this is my scale factor. If my 2 is my scale factor, what is my rule? 2x, 2y. There is my final answer. Y'all did that pretty well. All right, you try this one. Try this one. Find your scale factor, write the rule. Hold on, give everybody a chance. What's this new point going to be called? Prime of what point? So we can label that R prime. All right. Find your scale factor. Ooh. Might need to write it down so you can write the new over old. So R was 9, 6. R prime. Let me make sure I don't have that little negative sign right there. -3, -2. If I'm doing new over old, does it matter if I use x coordinates or y coordinates? No, as long as I use x's for both or y for both. Can I use x for one and y for the other? No, it doesn't work that way. New over old. All right, somebody give me a new measurement. All right, -3. Its corresponding old measurement? 9. Put that in your calculator. Find the scale factor. Make sure you're doing -3 divided by 9. Your brain automatically did 9 divided by -3. Make sure you're entering the -3 first. You should get -1/3. So if that's my scale factor, what's my rule? -1/3 x, -1/3 y. There's my rule. Okay? I don't feel like we're ready for homework on writing the rule just yet. I want to practice some more tomorrow. Your homework for tonight, though. No, I miss Marlon. Your homework for tonight will be to either go back and redo those last 3 problems if you didn't understand them, or if you didn't do the homework yet, do it and turn it in tomorrow. So you're either turning in or resubmitting your homework if you need to make corrections. Please make sure you get these notes glued in your spiral.